Hi guys, I'm Darren and look what turned up in the post today. Yeah, it's the SpeedyBee F405 WING. Okay, so this is actually the next day. My video software decided to screw things up, so unfortunately this has been opened already and I know what to expect, but let's have a look anyway, shall we? So quick thought about the box. I do like that it's cardboard, but yeah, there's no scratchy sniff stickers to see if this is genuine or anything. I bought this from SpeedyBee directly, so I know that it is genuine. Before we go into this, it did come with a small 8GB SD card. This was just in the envelope, it wasn't actually in the box, so I don't know if this is going to be a permanent thing, but if it is, nice work SpeedyBee. It could just be a promotion for the first X number of units sold. Small SD cards are getting harder to find, so if one is included, that's quite a nice touch. Right, so the first thing we get is the manual, where we have links to the SpeedyBee app, the installation guide, and their Facebook page. We have a load of stuff here, so this is what is included, I guess. So we have top board, we have a flight controller board, the PDB, we have the USB extension board. Wireless is supported, firmware, iNav and RGPilot. No mention of the actual targets, which is a bit of a shame, but yeah, you know it will run on those. And we have the power input, so 2S to 6S LiPo, the sizes, which is 52 by 32 by 19 millimeters, and the weight, which is 35 grams. This manual is actually pretty decent. It's quite long, so I'm not going to be able to get the whole thing on, but you can see we have the assembly instructions, the hardware for all the boards, the different layouts, what each board does, and then a couple of wiring diagrams. So you can see here for iNav, you just use the SpeedyBee F405 WING target. RGPilot, it just says load from local. So it probably means you have to download it from somewhere. Obviously they've got it working because this is Q ground control, so it must be working in there. So yeah, a decent manual. It'll probably be worth checking online in the future, just in case they make revisions to this. But yeah, it's nice that it's all there. And the paper feels like it's recycled, which I'm always happy about. So next in the box, we actually have the goodies. And I'm going to actually skip this for a minute and we'll do the boring part first. So there. Let's have a look at the accessories in the bottom part. So we have some pin headers, yellow, black, a couple of white and some red. So you can solder those on. We have a few baggies. This one is a more important one because it's got the USB header in there. This one is the standoffs and rubber gummies to build the flight controller up. And then we get another bag full of cables. Now, I'm not overly keen on all these cables because it means that this flight controller is littered with these plugs. For me, it's a hang up from coming over from being a quad flight controller manufacturer. For fixed wing, these aren't actually that useful because a lot of our stuff is further away, so we need to run wires to it. So solder pads for a fixed wing is a much better idea, but also they take up a lot of space. So the flight controller layout is compromised and you can potentially miss out on features because we've got these dirty great plug things on, as well as the pads for the solder joints. Now I'm going to grab this connector or this cable out of this bag because that is for our USB here. So let me grab that as well because we'll be talking about that in a sec. It does come with a little bit of double-sided sticky foam pad, so the attachment for this is sort of sorted out. Now, it looks like from the factory they've forgotten to take off a couple of bits. These two side pieces look like they should just snap off. We have a beeper, and the size of it, it looks like it could be a pretty loud one. Oh, I can't actually see an opening, so maybe it's not so bad. Fortunately, we have this switch here where we can turn it off anyway. We have a boot button, which we can also use to control the LEDs. we have a status LED, and we have a USB-C connector. So to connect this to the flight controller, we'll just plug this cable in, and then that plugs into the flight controller. Now, when I said I don't like the connectors, in this case, it's absolutely fine. But there is another issue with this, which we'll get onto in a bit. Let's get on and check out these. The first is the power distribution board. And if you check it out, they've even labeled it so you know which BEC is for what. So this section they've said is the servo BEC, but that actually includes the shunt resistor used for the current sensing and the header to go up to the second board. This section here is for the VTx and Camera. So on the side here, we have a jumper. So we can switch between 9 volts and 12 volts, or if you get rid of the solder bridge completely, it will run at 5 volts. 9 volts by default covers most systems out there. It will be absolutely fine. If you're running 1.3, sometimes you need to use 12 volts, so you can clear that bridge off and go the other way to get 12 volts. Or if you're running something like a Walksnail 1S VTx, then removing that solder pad completely will provide 5 volts, so that will be good for that too. On this side, we have the servo power. So by default, it's running at 5 volts. We can bridge the bottom two to get 6 volts, or the top two to get 7.2 volts. And if we flip it over, they even provide us with the information, which is quite nice. So we can see we have an input voltage of 7 to 36 volts. For the video BEC, by default, it's 1.8 amps when it's running at the 9 volts, 2 amps at 5 volts, or 1.8 amps at 12 volts. And for the servo BEC, by default, it's 5 amps, which is running at the 5 volts. Or if you go to 6 or 7.2 volts, it's 4.5 amps. So yeah, quite a nicely spec'd BEC system on this flight controller. So yeah, all good so far. Next up, we have the middle board. And this is where there are some nice touches, but there are a few silly little mistakes on this, which is a bit of a shame. Now, one of the first things I want to point out is that the screen printing isn't the best. So all these bottom pads here are ground, but you can see a G here, and most of the rest of it has been obscured. This middle row of pads here is the servo power, so VX for the servo voltage, and the top row is the signal out for the servos, or in the case of S1 and 2, the motors. This part all looks fine. It's a shame with the S1 and 2, instead of the power in the middle, they could have put a URX for getting telemetry from ESCs. This first block, if I pull the rubber back, is for connecting an S-bus receiver. So the top pad is S-bus, the middle pad is 4.5 volts, and the bottom pad is ground. All these 4.5 volt pads should power off of the USB. Here we have a connection for more receivers. So I'm guessing that S-bus is actually going to go through a hardware inverter and into RX number 1. We have TX and RX, 4.5 volt and ground. So this is where we could connect up Crossfire, ELRS, or any other sort of standard UART receiver. There is an analog RSSI in, which most people don't need anymore, but you could potentially use it for other ADCs. So yeah, nice that there's a pad for it. The only thing I will mention at the moment is it's a shame that they're using UART 1. Usually we like to keep that reserved for MSP just in case there's any issue with the USB. I mean, there's always a chance that this piece here could break off potentially, but I guess with SpeedyBee you do have the luxury of you have a wireless system as well. So maybe it's not so essential with SpeedyBee, but usually UART 1 is nice to reserve for MSP, and you can still run stuff on that UART that uses MSP, such as the SP32 radar. So it's not like it's wasted. But yeah, it's a shame that the receiver didn't use UART 2 instead, but there we go. So what I'm going to do now is flip it over, and you can see this is all repeated. We have some more information here. To be honest, this is information we don't really need. It's just got the barrow number, the IMU number, and the flight controller number, but this is all specs we could get off the website, I'm sure. The OSD is an AT7456, which is a sort of cheaper alternative to the Max. That's the OSD chip there. We have the flight controller here. Barrow, and I'm guessing that's the IMU. I can't actually see it, to be honest. On the bottom, this is the connector for our USB, and then we have some pads here. So we have ground, SDA and SLC for I2C, 4.5 volt and Airspeed. So the top four are going to be used for a digital airspeed sensor, and the bottom two and ground would be used for an analog airspeed sensor. So this is all just for an airspeed sensor, and we have 5 pads. On the top, we have these 2 great blocks, which are bigger than the 5 pads, and these are just replicating those 5 pads. We have a block here for an analog airspeed sensor and a block for a digital airspeed sensor. How do you know what connector the airspeed sensor's got? I know that they provide all these cables. It means you've got to chop them, join them. It's not pretty. It would be much easier just to run the cables and solder them onto these little pads. Job done. So you can already see what I'm getting at. We have a space here that is 16 millimeters, 16.5 millimeters, just for these 2 blocks, for something that is already on the board, which takes up 10 millimeters or less than 10 millimeters. So you can see that, to me, these are just a waste of space. Other things could have been positioned there. You could have potentially had more features. And the same goes for these blocks here. We have a camera block with 4 connectors, a VTx block with 4 connectors, GPS block with 6 connectors, and then this DJI block, which again has 6 connectors. And to be honest, we don't actually need a DJI and a VTx block. A bit silly, really. If I flip over, you'll see why. So this here is the DJI section. We have 9 volts, ground, T5, R5 for UART5. So that screen printing is a little bit dodgy again there. Ground and S-bus. And S-bus is going to R2 for some reason, where down here I think it's going to R1, which would make sense because R1's here for the receiver. So we're using R2 just for S-bus on DJI. What if we don't use DJI? We don't care about it. And there's no UART2 anywhere else on the board. So it would have made much more sense to use UART2 down here as telemetry for your ESCs. And so we don't need this here. If people are running S-bus on DJI, they can connect it in here. So back to the point, we have 9 volt ground, we have UART5, and we have a second ground, which we don't need. Here we have 9 volt ground, the transmit of UART5, so we're replicating this, and we have video. So if you just combine these 2 areas, we have 9 volt and grounds, they're both the same. We have T5, that's the same. We have R5 we can keep. We don't need this second ground. That could be the VTx pad. We don't need this S-bus 2 pad. So that is spare effectively. That's gone. These 6 here are for the GPS. So we have clock and data for the I2C, 4.5 volts for the power, ground, and the UART, which is on number 3. That could all be shifted up. At this point here, we have empty spaces for 5 pads. We have here our camera, which is again 9 volt ground and video in. So we would have 9 volt ground, video in. We have a space here now for camera 2 if we wanted a camera switcher, and we have another spare pad. So a bit more thought with the layout, and we could have had a few more features. The RSSI pad potentially could have been moved here so it's easier to access. We have UART 6 here. Maybe UART 6 could have gone on the top to be a bit more easy to solder to. There's supposed to be 12 PWM outputs, and I can't see number 12 yet. Right there, 12, but I can't see S12 anywhere. So yeah, it's a shame about all these blocks because I think that's a wasted opportunity. While we're talking about things that aren't great on this board, here you can see the barometer, and here you can see the SD card slot. Now this is actually causing 2 problems. All right, so let me put an SD card in. So you can see that is very close to the barometer hole, and if I put it so that you're looking down on it, you can see that there's actually a massive gap. If we were to use open cell foam to cover the hole in the barometer to make the readings more consistent, which we like to do, and a lot of flight controllers like this one actually have foam already attached to one of the boards, we're going to potentially still get air in that from around the SD card. The other issue is that there's a top board that goes on here, which is screwed down. If that top board is on there, you can't get to the SD card. You have to take that top board off. And the connections on that top board, there's 2 blocks of 8 and they're quite small. I'd worry about damaging them if I was taking that on and off all the time to get the SD card out. So yeah, if we'd got rid of these connectors or got rid of these connectors, there's plenty of room here now for an SD card reader. So the SD card could have been accessed there. So that's a bit of a silly mistake with regards to the SD card. It's not very easy to access. It means you need to use MSC mode to get the files off, which is incredibly slow. But other than that, it's a flight controller and it is dirt cheap. So there's not really a lot we can complain about. It's just, yeah, in a future version, hopefully some of these things will be taken on board and we get a fantastic flight controller for the money. Because, you know, when you think about it, if we're getting rid of these blocks, they cost money. So it's only 2 components that you would need for camera switching and also power switching for the VTx, which is not on here. You could potentially have a cheaper flight controller without all these blocks and have more features. But there we go. That's the overview of that board. Finally, we come to the top board, which the screen printing on this is actually quite nice. We have the labels for all the plugs, and we have some more plugs for the LED, which you plug into each of those. Now, the issue with the LED is I don't know if you can actually configure them in iNav. They're made to be changed by pressing the boot button. You click the boot button and it cycles through different LED outputs. They are programmable LEDs. It's whether or not you can actually change them in configurator, because you know you may not want the default flashy sequence that they've got. So it would have been nicer to have just an LED pad or multiple LED pads and you configure it in iNav itself. So yeah, I mean, it's a nice thought. It's easier to access if you just want something simple. We have this power indicator in here. So when you plug in a battery, you will see, you know, 25%, 50%, etc. With these LEDs. Whether or not that would be useful if the flight controller is buried in a foam model or not, who knows? But chances are it's probably not going to be that helpful. But it's a nice touch if your battery is in the same bay as the flight controller. This doesn't actually do anything, so again, it's another connector on there for no reason. And on this side, we have all the wireless stuff. So we have the Bluetooth Low Energy, the LED controller is on here. So yeah, again, that's saying that it's not really going to be able to use the iNav LED setup for it, which is a bit of a shame. This here is the BLE stuff for the SpeedyBee app, which is actually quite a nice addition to have on the flight controller. And that's what knocks it up above sort of some of the older flight controllers that this is so far comparing to. Okay, so here is the flight controller fully assembled, and you can see that it is quite nicely laid out. It has got rubber gummies in, but I don't really know what effect they're going to have because we've got these solid connectors here. So I think they're just for spacing. They're not actually going to do a lot for vibration. Maybe this side it's gonna have a bit more play, but you know, we've got a solid connector there. For this top board, we've got sort of 2 solid connectors at diagonals. So and that's actually on the top of the standoffs as well. So the suspension is just for this middle board, and on that side it's really not going to do a lot. But still, it goes together nicely. You can use the long standoffs to align the middle and top board so you get the pins in the right place. So assembly is fairly straightforward and, you know, painless really. But you can see a bigger problem here. These are the pads under here that are alternatives to these connectors here. And there's really not a lot of room between those pads and these LED connectors. So you're going to have to make sure that if you use these, you're pretty neat with your soldering. Otherwise, you may not be able to squeeze this top board down. So that, again, is another slight oversight, I think. getting rid of these definitely would have been better. I know a lot of people are going to say, but I don't like soldering, I like just plugging stuff in. But the fact is, we're going to solder anyway. We need to solder these. We need to solder these. If these leads aren't long enough, we need to cut them, put extension wires in, and then solder them all back together. So regardless of whether it's got plugs or not, you've got to do soldering. So if you don't like soldering, get a practice board and practice soldering. It's quite an essential skill for FPV. There's no getting around it. And by people just saying, oh, we can use these instead, it means that design issues like this occur. This end, we've got to get two lots of wires in. We've got the VTx and further back we've got the camera. So it's really not great having all these connectors on there. The other thing to bring up is the other problem with this. Let me plug this in. Now, as I mentioned earlier, I've got no problem with having this on a connector, and having this remote is very useful. The issue is it's not very remote. So about there, we can get it 85 millimeters away from the flight controller at a stretch. If it's coming out the front, you're about 50 millimeters away. It's really not a lot. And again, potentially we could cut these cables and solder extensions in, but it would have been nice if instead of providing all this lot, which potentially we don't even need, because we can solder directly on, why not just supply maybe 3 sizes of this cable? So we could maybe have a short one, but then a 200 millimeter long one, something like that, to actually make this as versatile as it can be. So again, that's a bit of a silly mistake, which again is a bit of a shame. I know it may seem like I've been having a go at SpeedyBee for a lot of this, but it's really not intentional. I just want to point out that there are flaws with this flight controller, but if you're happy with them, then go ahead. I'm probably going to get a few of these myself because, to be honest, the price point is fantastic. And I'm really not trying to dump on SpeedyBee. I'm glad that they've made this. I'm glad that they've sort of taken their first step into the fixed wing flight controller market. But to me, it seems like they didn't really talk to any fixed wing pilots, because if they had done, then maybe a lot of the issues that we see on this board wouldn't exist. It seems like a lot of it has come over from their quad board experience, but that's just my opinion. But at the end of the day, it's an F405 flight controller that will work well. This flight controller is cheaper than the F401 WTE. So as far as price point goes, there's no excuse anymore. Please stop getting F411s. They're just not feature rich enough. They don't have enough UARTs. It just makes life a misery when you're trying to connect up 3 devices that really should all be on a proper UART, not using soft serial. If you need something smaller, then the F405 WMN would be the better option. Don't go down the F411 route, please. Stop it. This is an F411 killer. If you've got a bigger plane and are thinking about putting an F411 in it, then that choice is just gone. And actually, I've just noticed, I really quite like this, this little SpeedyBee logo with the flying wing on it. That's quite cool. So yeah, I think SpeedyBee are going to sell quite a few of these regardless, but I'm really hoping that they stick to fixed wing stuff and, you know, maybe take some of this on board, and the version 2 will be just spectacular and hopefully at a similar price point. So one last thing before we go, I just want to do a quick size comparison. Here we have the original F405 wing from Matek, and to be honest, feature-wise, these two are very similar. This is an old flight controller. It doesn't have camera switching, it doesn't have VTx power switching, and it only has 9 servo pads on this, so compared to the 11 that I've actually found on this one, even though it says on the other side of the board that it's got 12. I can only see 11 on here. But yeah, this one has 9, this has 11. This is the F765-WSE, which is a bit more modern of a flight controller. It has got the 2 cameras, it has got power switching for the VTX. It has got a sort of onboard SD card, if you like, but this is on the top plate, so it's easy to access. Of course, the Matek F405 wing, it was on the side. But this was mainly just to show the size difference. So it sort of sits in the middle-ish, slightly closer to the F405 wing, but you've probably got about 10-12 millimeters difference here, about 7 or 8 millimeters difference here, and if you go for the width, again we've got about 5 or 6 millimeters difference here, probably about 4 or 5 millimeters difference here. Size wise, it's not overly big, and it'll be fine for most planes other than like the smallest, lightest sort of planes that you've got, in which case F405 WMN would be a better choice. But for most average size planes, that's absolutely fine. That is not only just the logo, but also the direction of orientation. That's very cool, because at the back we have all the servo and the power. So yeah, nice incorporating that into the logo. That's really cool. Right, so what are my final thoughts about this flight controller? I think that it's going to be a good flight controller for a lot of people, to be quite honest. I mean, even though it does have a few little issues, I think that a lot of people will find this as a really useful flight controller. Now, it may seem like while I've been doing the unboxing that I've been being a bit harsh, and that's because I had sort of high hopes for this. It's just that there's a few silly little mistakes on here, which if SpeedyBee had reached out to fixed-wing pilots may not have even happened. But for a first attempt at a fixed-wing flight controller, it's pretty good. And at the price point, hopefully it will stop people buying F401s finally, because they are a pain in the arse. They don't have enough UARTs. You know, stop it. No more F401s. Get this instead. So yeah, good first try, SpeedyBee. Hopefully the next one will be better. But I will be giving them some feedback. But I hope you guys found this information useful, and if you did, please remember to give the video a thumbs up, click the subscribe and bell icon to help get this video out to more people so they can learn a bit about the F405 Wing too. And I'll see you on the next one. Please remember the most important thing, enjoy the hobby. If you're in the Northern Hemisphere, good weather is finally starting to show up. So get out there, fly your models like you stole them, have fun, and yeah, just enjoy yourselves. Thanks for watching, guys. See you on the next one.